Displacements give us more control over the shape of the hair than we did with the clump and hair shape attributes. Let's select the hair and go to the attribute editor, Control A, and open up the displacements section in the hair system shape node. And you will see in here we have curl, noise, and subclump. Let's take a look at curl first. You'll notice that there are separate amplitude and frequency attributes here. So curl is the amount of curling, and curl frequency is the scale or the size of the curls. And if I have a high frequency, you'll notice that my hairs look a bit jagged. This is a perfect example of when we would need to increase the number of substeps. So let's go back up into the clump and hair shape attributes, open that up, and increase the subsegments up to a value of, let's call it 2. And now you can see that the frequency of that curling is too high. So go back down into the displacements and reduce the frequency to something that looks good. Value of about 4 looks okay in this case. Once again, you've got a separate amplitude and frequency here. Scrolling down a little bit, you will notice that there's a displacement scale graph or ramp. And this affects all of the displacements, all 3 of them, because we've got curling, randomness, and subclumping. And this, once again, is the root of the hairs and the tip of the hairs here on the right. So if I give this a value of 0 throughout, then we will have no displacements. And if we create another point on the graph here and move that up to the top right corner, we're saying we want full displacement at the ends of the hairs and no displacements here at the roots. Very good. So that's how displacements work in general. I'll turn the curling down again, and we can look at randomness. Random noise has an amplitude as well. I can increase that value. We will get more noise. And it also has a frequency. As you can see, we can control the size of the noise. So we can see that more clearly. I'll set my displacement scale to be a constant value of 1 once again. We've got the scale of the noise here, and we have the amount of the noise here. We have different types of noise. If we go to the noise method, you will see there's random, surface UV, and clump UV. Random sort of treats each individual hair by itself and applies a noise to the hair sort of by itself, all alone. Clump UV affects each clump separately. But it's a strange paradox that clump UV tends to make the clumps look similar to one another. We've also got surface UV, which is actually a volumetric noise. And that's the one I prefer because it's the one that looks the most random and the various clumps all look different from one another. So we've got the amount of the noise, we've got the frequency, which is the scale once again. And within the frequency, we also have 3 parameters for frequency in 3 different dimensions, U, V, and W. U is one of the UV dimensions, V is the other UV dimension, and W is the length of the hairs. If I play around with noise frequency W, you can kind of see what it does. With a low noise frequency W, our noise has a long wavelength here. And with a high noise frequency W, we've got a tighter, shorter wavelength or higher frequency. Finally, there's detail noise, and that's another level of noise that's added on. So if you get in really close and look at it, detail noise adds another sort of iteration of noise onto the first one. All right, so that's noise. And then finally, we've got subclumping. And this is good for giving the effect of hair that's wet and sticking to itself. And as the name subclump implies, it's causing clumps to attract within one another. We'll need to increase the subclumping amount to see it happen. And we'll need to play around with the number of clumps in U and V. The default value is 15 here, which is a pretty high value. We usually would want to bring this down a bit because that value is so high that it's not really working well here. What we need is each clump to clump into maybe 2 or 3 or 4 subclumps. So let's reduce the number of U clumps and the number of V clumps to something in the realm of 3 or so. And now you can see if I reduce the subclumping amount, it's a bit clearer what's going on here. Each one of those clumps has now got 2 or 3 clumps within it. We can make that even more dramatic by going back up to the top here and increasing the clump width. And then going back down and increasing the subclumping amount. And now you can see we're getting the effect of hair that's sticking to itself in regions smaller than 1 clump. Okay, so those are all of our displacements: curl, noise, and subclump.